Good evening. Welcome back to the world after in person. So we worked in content generation for many, many years, even before deep learning was invented. Well, before 2012. And back then, content generation was not really like generative model. For search engine optimization, we would take different reviews and crossbreed them, like to produce kind of original opinionated data. So that was attempts more than 10 years ago, attempts to build content generation for the purpose to convince search engine that there is original content. So here we are 10 years later. Truth-O-Meter. So impressive capability, no question about it. However, there are a lot of all kinds of hallucinating, non-existent, incoherent content, and then it can undermine potential merits. It could be a lot of problems, and to me, that's the biggest limitation of language model today. Significant challenges, error in terms of factuality, reasoning, math, coding bias. And these limitations have been carefully explored. But a lot of exploration of the limitation happened after ChatGPT appeared. However, our group, we worked with a long time ago, starting with GPT-2 and GPT-3. So now ChatGPT has much less errors. However, whatever we learned trying to repair GPT-2 and GPT-3 is very useful, because it used to be we have to fix every other phrase. Now we have to fix maybe one phrase in a paragraph. So this is different in scale, but we already prepared because we put so much effort 5 years, like 7 years ago, into this idea of repairing language model. And in general, I'm more pessimistic about neural content generation than most people in the field. So I think I intuitively feel, okay, essentially what a language model does is getting a lot of an averaging. And averaging is not always works. For mainstream, it is working, but for tail things, it makes mistake. Let's start with example. That's a recent example. That's GPT-4. Let's say I just spent a month in Nepal. I was curious what GPT-4 knew about it. So valley, high altitude, higher speed, but then the number somehow average. So what the system does, it takes a sentence, it searches on the web, it goes to multiple sources, it compares results from multiple sources and figure out, first of all, there's no such thing as 6,181. There is 7,181. And from that, you could kind of figure out. So what language model does, it averages character by character at some level. Yeah. So that's not a random number. That's some kind of averaging. This is something else. But in general, you can see at character level, you cannot really maintain meaning. So first of all, it's not the highest point on the track, it's a visible point on the track. It's mountain, not you get there, you see it. There's a serious difference between. So these kind of errors, language models still doing. However, this information is available. Web knows that. I mean, there are sentences on the web you can find if you ask carefully that there is different mounting visible, not the point of the trail, and then the actual altitude. So there is a GitHub page, and there's explanation how to use it, reference to the patents, so right now you can use it pretty simple. It's like couple of lines, just couple of lines of code. This library is on the web. You need to get being key. Yes. So we first talk about GPT-2, GPT-3, which did a lot of errors. So it's a really good test bed to learn what to do. Then apply this to modern ChatGPT, compare with others, look at other architectures. If you have time and interest, that's like from machine learning. So what from this project, in terms of general machine learning architecture, what do you learn? You start with deep learning, then you do stuff on top of it. And I should say, over the last, well, 5-7 years, mostly things they did at work, I would take a deep learning model, and then whatever needs to be done to wrap it, whatever needs to be fixed to make it work. So how can you generalize from this? And probably we don't have, if no questions, then we'll get the other important issue with ChatGPT, how to control initiative. Right now, ChatGPT doesn't have much initiative. It just answers questions, and confess that it was wrong, if it was wrong. But what needs to be done to make it to take initiative? If you have time. Again, a language model impressive, great performance because they have vast amount of knowledge, but not everything you can do with averaging. Nevertheless, knowledge not perfect, memory distortion, and then we have to focus on forced information, which is now called hallucination. But in GPT-2 and GPT-3, almost everything was hallucination. There was like some lucky coincidence with correct facts, but almost everything was hallucinating. So moving from GPT-2, GPT-3, and GPT-4, significantly less hallucination. So there is improvement. But essentially, you cannot get, I believe you cannot get rid by internal means. And again, fact-checking is a separate research area, mostly focused on misinformation, and in a lot of examples from politics. This is different. Like intentional misinformation is one thing, and hallucination is kind of not intentional. Large language models, they don't intend to hallucinate. It's just by the nature they are designed. So there's a difference. Okay, so one way to look at this problem, we have, depending on the purpose of generation, we have language model content and we have true content, and we want to merge them somehow. And we're going to look at general linguistic framework, how it can be done. But in general, a language model, very nice overall content flow. Overall looks, sound very smart. So we want to get there. Factoid, as much as possible, we want to get from the web. So trying to merge best, crossbreed the best of both worlds. Language model original and the great flow, and the web sometimes not well organized, but most facts, we assume facts are truthful. So coming back to our example with mountains. So what are the steps? What do we do? From a sentence, we build mostly noun phrases. How to search the web? We cannot usually we cannot search the whole sentence because then search engine is confused. So we take sentence, build noun phrases. From noun phrases, we build or query because we don't know which will actually occur. And then we're using traditional TF-IDF relevant mechanism to make sure existing plausible parts matched and implausible don't make like zero results. We search against the whole web, and then we try to select sentences which are closest to generated. And we focus on this procedure because this is interesting linguistic structural procedure. And this is all deterministic. So we will actually look at what is the structure of raw content, and what is the structure of true content, and then we see how we can merge structurally. And again, what we take, this table shows what we take from both worlds. This is ChatGPT, this is the web. And then we take different parameters: source, syntactic, discourse, reference, and so logic, and so forth. So we decide what we take, again, ideas, like very high level, we take from ChatGPT, and factual and syntax around factual, whatever concrete, we take from the web. And this, like when I say merging, this is a linguistic alignment procedure. So we have sentence, and that's what we're going to spend next 10-15 minutes looking at examples how we match. These are examples in medical domain. This is generated text which is not true, and what we see that blue is the same thing or synonymous, and red needs to be repaired. So this is all true, but maybe different context. This is the context we want, but whatever is red, we need to fix. Example from literature domain. That is again all the GPT-3 biography of a poet. It starts first few tokens are true, but then it's totally random. An existing person in an existing place offers translation from different language which never existed and so forth. So we take, and again, ChatGPT is not as bad now, but if we can deal with as noisy data, then we can expect that with modern ChatGPT, GPT4, GPT5, the better language model, the less things we have to repair. But we have to learn how to repair from the data with a lot of repair required. That is why we are talking now about all the GPT-2 and GPT-3. So again, we find actual data in terms of different century, different translator, different work of literature, and so forth. So in this case, GPT just gave idea that if it's a biography of a poet, then this poet probably communicated with some other people, with translation, whatever. So in this case, it's a very broad idea and very concrete stuff we get from real data. Now with modern ChatGPT, the other way around, we have to adjust and verify little things. Now, linguistic representation. So a lot of examples here will be in medical domain. On one hand, it's more responsible, and errors are costly, errors are really dangerous. But I try to make a point that, so what's the purpose of, in general, writing? In healthcare, in a lot of cases, it's hard for a physician to keep in memory a lot of different diseases, a lot of different conditions. So in this case, ChatGPT helps because ChatGPT can actually capture a lot of cases. And whatever ChatGPT, we try to find errors in ChatGPT and fix, and assume to be this to be better than like human. So what is here? We have syntactic. So we have, this is not content generation. This is like real medical misdiagnosis problem. We have misdiagnosis and correct diagnosis, and I show you in linguistic structure. In color, this is syntactic representation, and errors are syntactic connection between words. This in trees are semantic representation. Semantic representation is much broader. So syntactically might be different, but semantically might still be the same. So we don't always have to fix, change, and correct syntactic representation. However, it has to be met. So first, for this case, syntactic is mapped into semantic, and for correct case. But then in turn, this whole thing, correct is mapped into incorrect. So green shows this is correct, and red shows this is incorrect. This has to be repaired. Means take correct diagnosis and substitute whatever is shown in red, take it here, substitute there. Okay, maybe questions here because this is a little bit deeper in linguistics.
The top is syntactic, the bottom is a semantic graph.
No.
Yeah. And
So we have this top, this is bottom.
Yeah.
Top has syntactic, semantic. Bottom has syntactic, semantic.
all right, so the nodes are semantic in both cases.
These nodes are semantic in both cases.
Yeah.
So
And
this mapping shown between semantic, but to derive this, you have to have syntactic.
And so one of those is a parse of the language model output, and one of them is a parse of content that was
Okay, theoretically,
right?
this is raw, this is language model,
Yeah.
this is true part. However, specifically to show the point, this is not language model. This is a wrong diagnosis made by human. Now this is correct diagnosis made by human. I specifically wanted to show that there's no essentially the same thing. How you correct human mistakes and machine mistakes. It's the same thing. That's another example, medical domain. Again, biography. GPT-3 starts and then goes pretty much randomly, whatever. And using Google search, we correct this. And again, everything in true is in highlighted in yellow. You take data from true and substitute into red. The same thing. Again, GPT-2, GPT-3, you have to do it with every sentence. Now, like one sentence or one phrase in a paragraph.
So your system has a representation in a semantic graph form of content from the web, and it's finding the most similar semantic content to what the model did by matching semantic content trees.
Yes, but on demand, because obviously I cannot have semantic representation of the whole web, because when I search the web, usually I find using just web like the default Bing search, Google search default relevance, it gives me few. And then for few, I can do semantic analysis in real time. Obviously, I cannot index the whole, build the whole semantic web for this. This is another fact-checking, like particular drug recommendation. Green supports, red defeats. So this is how we try to correct. And this is the next level. We have syntactic analysis, semantic, and this is now discourse level. This is even higher, it's even more abstract level. Discourse analysis show how authors organize their thoughts. Why do we need it here?
So the discourse is over many sentences, correct?
Discourse goal is at least starting from a paragraph. This is a discourse of a document or discourse of a paragraph of text. It's mainly how authors organize thoughts, organize entities in text without, doesn't matter what the text means, like abstracting away from semantic. And this procedure which I described actually breaks this whole thing, because we repair it. We substitute phrases. Sometimes we remove the whole sentences, and then we break the discourse. So to do that, we need to try different, in real life for GPT-3, we need to try different versions of correction and then see if this version maintain discourse. How you maintain discourse? You make sure that the new repaired text have the same logical structure as the original text. Because now we repaired factuality, but we brought overall organization, which is also inappropriate. Now this problem kind of disappeared because as ChatGPT and GPT4 is better, you repair not every sentence, and then usually you don't break discourse. But that's a good, again, good illustration. This approach prepares, if there's a problem with discourse, it can also be repaired, and how to do it. High-level architecture. We check if sentences is acceptable, go one by one, find suspicious entities, run queries for each. Again, this procedure which I showed semantic and syntactic level in G, it's called generalization. And generalizations, by the way, the key operation in learning in general. Just deep learning model generalization is implicit, but in old-fashioned traditional learning, like inductive learning, generalization is particular rule. You have data, you derive rule from data, a rule can be written. So rules have certain structure. So generalization used to be visible. Then you do alignment, check if sentence can be used, sufficient finding on the web from true data substitute entities and so forth. We're going to look at new modern architecture. So this is like a few years old now. And some evaluation. So for this evaluation, we took different web forums. It's a drug recommendation. Why we need content generation for this? Because now we have a certain medical condition and certain peculiarities about particular patient. And then the doctor has to manually write, taking into account a lot of knowledge. That is why, although it's not really, it's in real life, it's dangerous to do that. In healthcare, that's a good illustration example. And that's a more difficult text generation problem than most like in marketing. So again, I'm counting how many sentences, how many facts need to be substituted, and then total number of raw sentences used, how many total number of true sentences from the web need to be used. So that's some understanding what is happening. And now moving on to ChatGPT4, ChatGPT and GPT4. So what do we do? That's now totally different level, totally different examples. I'm asking here who led the expeditions to the deepest cave in the world. So green is true. ChatGPT found correct about this particular deepest cave, it has correct information. But about the group, it has incorrect information. So that needs to be repaired. And Wikipedia knows about it. So in this case, you go to Wikipedia, you find, you do like narrow domain question answering, machine reading comprehension, like who led from this page, who led expeditions. And from Wikipedia, once you have this Wikipedia page, which is easy, again, easy to find because by the cave name, you find the person. Just need to do this multi-step procedure. And then you substitute again, you substitute red with green.
So as a caver, how deep have you been?
800.
Okay.
So like not even half of that. So that's not even half of that. Maybe third.
No, 7,200 is the deepest, so that'd be like a little over 10.
Okay, so in feet, the deepest is 7,000.
Oh, okay, so you did 800 meters.
Yeah, so like
Okay.
two something, 2,000 something.
Oh, wow.
Okay, so what needs to be done? So again, check by, you have to still check sentence by sentence. It's not that you can cherry pick whatever. It is current. First sentence usually correct because system starts deviating step by step from like third, fourth, fifth sentence. Extract entity, identify wrong sentence, obtain entities from wiki pages. But from wiki pages, Google can also do it. Just from wiki pages is more accurate because one way to find Google snippet, another way to find a correct wiki page, and then within this page, just apply a modern question answering machine reading comprehension to short, then it works. So like this formula, web search API plus a local search, just short search of a single page is more accurate than this whole huge model, which is obvious. And again, Retriev is used, Retriev is a part of a modern architecture for search, which is not index-based, but based, obtain value for certain entity. And two parts. You'll be using evidence external knowledge from the web. And then another approach, kind of competitive approach, is still use LLM. But now, once you have a hint, once you have additional knowledge, say, okay, now you LLM, now you have this knowledge, apply it and try to produce. And these are competitive approaches. Like Truth-O-Meter, it's mostly, okay, leave language model alone. Whatever it did, use it, and then try to fix everything by external means. But there are very popular approach using reinforcement learning, come back to deep learning with additional data and still try to improve it. And it can be done by iterations. So these two architectures are clear.
But you're saying, I mean, like GPT-4 used the reinforcement learning approach and it improved its truthfulness, but it still hallucinates.
It hallucinates. Then using a second approach, you take GPT-3 result. You go to this Wikipedia page. Now you come back to GPT-3 and say, like, here's Wikipedia page. This is true. Try to correct whatever you can. Sometimes it is correcting, sometimes it's not correcting. So it's a question. It's better to do it like using my code or go back and using language models.
How are you scoring correctness? So you generate an answer, and are you manually checking that every answer?
Okay.
To label it as correct or not? Because or you have some automated way to mostly.
So there are sources on the web with question, data set with question and answers.
Okay.
So answers we can trust. Then you automatically using ChatGPT4 API ask questions, get the answer, and compare it with then you that's experiment number one. Experiment number two, you apply Truth-O-Meter.
But the comparison of the generated answer to the known truth answer.
Yeah.
That process is what I'm.
That process is very well known because that's the foundation of how GPT-3 trains itself.
Okay.
So there are many different measures how you like a lot of the whole world how many measures to check for similar texts. So that's a very well developed area and a use standard.
So the wrong answer generated here we use for training the future ones?
That is already done in language models. But in my case, again, I take a data set of true answers, ask ChatGPT.
The two is subjective, right? Because
No, in this case, we assume we can argue, but these data sets are manually curated, and they're not huge. They're used for other question answering tasks, but they can also be used for this fact checking. But again, we can trust the answer. We assume that the answer is the same as you would find on the web, and then you compare ChatGPT without Truth-O-Meter and ChatGPT with Truth-O-Meter. Now hallucination types. Not only, we only talked about domain-specific knowledge, but it makes sense in common sense knowledge. So some stuff, some errors you can find not necessarily factual, but just looking at text and applying some logical rules, like conflicting with preceding context, conflicting with succeeding context. Those just additional verifications which is done on text, which do not require going to the web. So only this one, only domain specific, you need to go to the web, and the rest you can either do rule-based or you can do like particular, not general language model, but language model fine-tuned for particular tasks. Like for example, find conflict, find relation to central topic.
one question.
Yes.
How do you say that I will not report that only a specific what's important to
So repeat it.
Okay. So the question, how I build language model. So I do not build language models. I use existing and then I repair them based on going to the web and then using structural approaches.
I understood. And then how do you do the domain specific knowledge?
Okay, everything domain specific, I assume you cannot train, you go to the web. You take exact fact.
Right.
And the rest, you just take models from Hugging Face. We may be fine-tuning, maybe not. So for most of these, you already have available models. They don't find all these issues, but pretty much once you have training set for this, it's not too hard for language model to identify this. If it's specifically, so it's hard for general language model like GPT to take care of everything, including this. But if you have trained specifically identify these problems, that is much easier. Like this, a network would know anything other than find, like, classify text into yes or no in terms of like this conflict.
So we need
Yes.
back up with the training data, the answer matches with the training data, then the domain.
Okay, so
Repeat the question.
okay, so the question is if I do any matching with training data. Let me repeat the evaluation procedure.
So the thing is, how do I know what's the domain specific? And how do I know what is not domain specific?
Okay, so I assume everything is not domain specific. I take each sentence. From each sentence, so I have questions, send questions to ChatGPT. I get text. And from this text, I don't know anything. I don't apply any knowledge. I take each sentence and then go to the web. What I'm saying, what I described above, before that, that's only domain specific knowledge, because this thing is just additional verifications which can be done without specific knowledge. But this is still the main thing. These are not factual, they are factual errors, but they can be identified without using the web.
So in other words, whatever that is specifically trained with preset data for a specific field is what you would consider.
Okay, so conflict recognition, it's not domain specific. It's a pure syntactic thing. So these are obviously not domain specific. These are syntactic things.
So the others are process of elimination. Domain is what remains after being elimination.
So this can be done independently. They just improve overall accuracy of content repair. So again, this is done against the web. This is just a classifier. This is classifier, or think of it. This is a detector which takes a syntactic tree. It doesn't even need to know exact words. Just need to know like part of speeches. And then, like document writer cannot be civil rights attorney. So writer and attorney just different now.
I mean, I'm looking at the bottom ones and thinking to myself, I mean, this is like, it seems like you have to solve the understanding problem. Like, it says he was born in April. You have to, know that he refers to Alfonso Flores Ortiz, and there's all the subtleties of language. It seems so hard.
Okay.
I'm wondering if, like
Okay,
you almost have to.
I just want to add to that, like, to me, and I'm not knowledgeable about this whatsoever, the conflict with preceding context is also semantic relationship, right? In terms of dates, there's a semantic relationship in the dates, so that 1992
Okay.
comes after 1987.
Okay. So how the you have positive training set and negative data set. Positive when this relation is correct. Negative when it's not correct. And the system tries to find. For us, it would be like finding common sense knowledge chunks. But essentially, system will form syntactic signal. What is common between positive training set and negative training set? And it turns out, so for negative, these numbers are inverse. And for positive, they are not. And that will be huge. I mean, GPT-4 language model has it, but because it has so many different, it's so multidimensional. Are there, like when it actually writing, are there dimensions take precedence for some reason? That is why after ChatGPT, you either apply a rule base like this, or you apply a specifically trained model just for, which has like 10 nodes in the space of 10 parameters. Think of like numbers, maybe synonyms, references, and so much limited. So for limited space, you can reliably learn. For unlimited, think of ChatGPT, unlimited space, you mostly guess right, but sometimes you guess is wrong. Yes.
On the top of your screen, there's 3 Q&A people from Zoom that were submitting questions. At some point, convenient to you, if you could answer some of those.
Maybe at the end. Or sure.
You use your judgment if you can get to the questions at some point.
Hard for me to switch. Okay, now we are moving on to a very different area. Now we're moving on to traditional logic. Okay, in our example for keying, we have multiple sources. Now think of it, one is Wikipedia, and now there's different pages. And different sources defeat or confirm different parts of ChatGPT text. What do we do? So before, we always considered simple example. We have raw, possibly incorrect text. We found ground truth, and then we cross-match them. But in a lot of cases, there are multiple truths. So how do we deal with multiple truths? And for that, we use argumentation theory. Approach here, we have what is called non-monotonic logic, which is different from classical logic, that some facts are always true, and some clauses, some rules are always true. And some rules can be defeated. They most of the time they're true, but sometimes they can be false. And it's important to differentiate between them. That's one part. Another part is called natural language inference. Natural language inference, there are specific library on Hugging Face. There's a library, textual entailment on Allen NLP. So you can use it out of the box. And for the sentences, you can automatically derive which follows which. And then, assuming all of them are true, unless all of them are true, unless they're inconsistent and proven not true, you can apply natural language inference and see which are the most reliable, given the other, which are the less inconsistent. They can be inconsistent, but which is less inconsistent. Then it turns out that S1 implies S2, S3 does not imply S2 defeats. So this is the relationship, what confirms, what defeats what. And then S4 turns out to be the best. It implies almost everything. And how can we do it automatically? So we take, if we do web search and we ended up not finding one best true sentence, but multiple, like web search based on keywords found multiple. Then we applied natural language inference and see which is less consistent. And then we build what is called argumentation dialectic tree. And this technique is taken from argumentation theory, not related to linguistic, really, not related to language models. It's an older theory, maybe 10 years old. What happens if you have, in general, multiple conflicting sentences? How you figure out at the end of the day what is less conflicting? And again, this is a technique out of the box, which can be applied, and then we find the best true sentence. You find the best truth. If there are multiple truths, we find the best. Okay, maybe question here, because this is really like step, and this is more classical logical AI problem and technique which is applied when we have multiple candidate truths. Okay, for example, I give a simple example. So how to figure out what the best candidates? I give a simple example here. Like I have 3 friends. One friend lies once per week, another friends like every day. Then both of them can say truth, right? But you'd rather trust the guy who lies once per week. But then lies become correlated. It becomes logically more complicated. So it is a pure logical problem, like no learning now. And it turns out that if you have multiple facts, on their own, they all look truthful. But if they conflict each other, you just find the one which is less conflicting. Okay. And this is web, so they're random. Okay.
I'm wondering if this would solve a common problem that I've seen on language models where syntactic structure will overwhelm common sense. And so if you ask language models something like, John found the solution to world hunger, but it requires him to call Jane, who once in 2nd grade told him that his shirt was ugly. Will John follow through and say, no, John will definitely not call Jane because that grudge, because the way that it was phrased,
Okay.
it like completely, even though it was solving world hunger, if you ask it, it'll say, yeah, solving world hunger is really a big deal, but that childhood grudge is going to be too much, So I was wondering if defeasible logic could actually like correct that.
Maybe I should use your example. So now we take each sub-sentence, like each phrase, look information on the web, solve word hunger, have certain phrase, friend, context, or whatever. Natural language inference model will confirm that they're all independent. That to save the word from hunger, it's not like about calling somebody. Because natural language inference model knows a lot of different examples of true syntactic links, and then it deduces like logical links. And then you'll get information like go to the web. You probably get 10 different ways how to save from hunger. You find that they are independent, and maybe some of them which somehow correlated with other parts of sentence you said, those will be selected, and those which are not correlated with calling somebody will be rejected. This again iterative mode, which I mentioned, instead of taking ChatGPT and just forget it, now we go to the web, we go to logic and fix everything. We can explore, we can mine for additional information using the same techniques, and then go back to ChatGPT. And this is, as I said, competitive approach. More modern architecture. What do we do? First of all, yes.
Less conflict, detection of conflict.
Yes.
So that is based upon the attribute.
No. Okay.
Can
No.
you repeat the question?
Okay. The question is how conflicts are detected. So because almost everything these days is done using training data, specifically showing how resolving conflicts can be done without training data. So you use training data to identify from conflicting sentences which conflict, and once you have the structure, pure logic, like crisp logic, can be applied to the structure. At least at some step, you don't use learning, which means that it's all 100% explainable.
And if there is a conflict in that predicate.
Oh, there is always kind of conflicts, different conflicts in training data, because training data is arbitrary text, right? There's always conflict. So that is one reason we get hallucination. But when we verify hallucination, we go to the web, we get again conflicting search results, but then finally we use logic to try to clarify and resolve this conflict. Just select something less conflicting.
It means we are actually comparing against Google search results.
Yes, assuming Google search result is true, so each individual result is true. However, different results can contradict each other, but that's okay because we apply special logic for that. Okay, so we have decomposed how to simple way just fact check each sentence. However, in different documents in different genre, not every genre has to be verified. For example, opinionated data in customer reviews should not be fact-checked, or maybe should only be fact-checked statements about products, but not opinions, because opinions, they're independent. So in general case, we need to first, before we do fact-checking, classify text into this is checkable, this is not checkable, checkable, not checkable. Next, decontextualize. Some sentences have important entities in previous sentences linked by coreference. So then we need to add. Then we identify check-worthy claims, retrieve and collect evidence, and now what I described in terms of conflict in general case, linguists call them stance, like how trustable is each part. And then we have multiple opinions. For example, now we have multiple sources. We have web, these are organizations, we have web, we have intranet. How do we resolve conflict? In general, this is called stance problem. So conflict is a partial case of it. Then we do substitution, which I showed like in my mountain example, combine, and then so possibly offer to the user for manual editing, and finally the out. So this is so before I showed architecture like 2016, 2017. This is architecture 2022, 2023, more modern architecture. And then evaluation now for the same data set in health forums, and it's much better performance, obviously much easier problem, and most of sentences we don't have to do anything, and that's why like precision recall of extraction is much higher. So when you find the factual error is most likely true, and whatever you're suggesting, whatever value you're suggesting from the web sentence is most likely correct. Yes.
Question. So if you correct something, are you able to give a confidence in your correction? Sometimes it's great to tell users, here's my best answer, but I'm less confident in it. And maybe they can kind of deal with that.
Not really, no idea, not because it's like the process is the final process deterministic, there's no score, it's rule based.
Okay.
So in the overall architecture, each step is probabilistic, but then finally, based on certain threshold, we said, okay, now we substitute, and it's hard to tell.
Okay.
Hard to tell confidence.
So let's say the next slide is the medical way.
Mhm.
Like I said, bloating is linked with eating bananas,
Okay.
right? And if that paper has been cited by 10,000, that means it's more, where did it come from?
Okay. So if I found a document on the web confirming, I have this threshold, how many documents on the web I need to consult to confirm. So, for example, if some random thing, maybe incorrect thing, but if there are multiple sources on the web confirming it, I'm saying yes, this is true, because I'm not verifying the web. I'm assuming whatever source I use, I trust it 100%.
But some sources are more reliable. So I said, some nature, so the paper is published in Nature, that is more reliable.
Totally understand, not there yet, because it's important addition. So maybe ChatGPT 6. Which will hallucinate once on a page, not once in paragraph, but once per page, then this will be useful. You know, because there are many more there are more important, like more serious problems. Like hallucination is really random, and you fix serious bugs. In confidence on the web, it is helpful, but it's kind of secondary signal, not as important as it's like explicit, like totally random value. So most important, totally random, and then if you find at least a couple of sources on the web confirming, I would say search engine knows the confidence. So I just trust search engine knows the confidence. So search engine will give you like Nature paper on there first, and somebody else's Boris's comments on the problem on page number 100. So I don't have to worry about it myself because search engine does it well. I mean, relatively well.
Is that why the first sentence to the problem?
I think that's by the nature of, I would say by the nature of token prediction. So it starts, so in a lot of cases, first, in a lot of cases in ChatGPT, first sentence is introductory. Like in real life, we should ask doctor, but then.
Yes, and any links to the reporting citation, like.
As I say, since I use search engine and search engine does it for me, I don't have to do it. I just trust search engine. I don't have to do it myself. I mean, I could because I don't really use. Oh, by the way, I'm violating terms of service for search engine. Search engine is not designed to do fact checking. It's designed to serve people, right? But I'm mentioning this that it's not ideal ordering, like ideal ranking from search engine, but it's good enough because there are other many difficult problems, and that's not number one.
Search engine is ideal for selling ads. It's not ideal for generating facts.
Yeah, for fact checking.
But you're saying it's close enough.
Good enough, because there are more other issues, which see like 15% of errors mostly due to other issues.
Google uses this section now, you said fact check, and they always I see like 4 or 5 articles. Google.
So I'm kind of trying to do the similar thing.
Are you using Bing for your Google
I use
search?
both Google and Bing.
Oh, you are.
Both, because Google recently available again now.
Quick question.
Mm-hmm.
This might be a really high level question. At this point too. How do you differentiate what's to be believed
Okay.
versus the truth?
Okay. How I classify opinionated data versus.
Believed to be, because they could be really high, right? In the ranking. I mean, I can give an example.
Okay.
Most people believe that there is God,
Okay.
right? So how do you differentiate that which is true?
Okay, so I assume I delegated to search engine. If somebody is saying I have a God and God's name is ABC, if I find somewhere on the web confirmation, although maybe a lot of documents are saying this is not true, I'm not considering this as a wrong fact. So I allow, because if it's on the web, then I think it's okay to ChatGPT say this. This is not hallucination at least. So I'm not arguing with the web. If I have.
Yeah, your philosophy is the web is the expert, but you're not doing other philosophy debating beyond that.
Yeah, so if I have confirmation on the web, maybe minority of people believe that, maybe majority, but if I have confirmation on the web, then I think it's okay for ChatGPT to write like that. Because hallucination, usually, it's not confirmed on the web.
Is it the case that a hallucination that is off a little bit, you're likely to find something similar enough to detect that it's wrong, but a really wild hallucination won't have any matches at all, and so you won't be able to detect it?
Really wild hallucination will not have any matches. That is why I detect it. So if I don't find anything, any kind of confirmation, then I just reject the whole sentence.
Okay.
Oh,
So if I find, but it's used to be in GPT-2, but not anymore, not frequently.
Okay.
Because when you average through a huge amount of data, even bigger, then for any domain, there's enough document. So you make errors, but not totally somewhere in something unexisting, in some unexisting world. Okay, so I mentioned some different architectures. One approach is let's just again do everything using learning. let's just predict based on token level. And this works for in cases when there is no web. For example, it's domain which is not on the web, non-public domain. And then it turns out if you automatically learn probabilities between tokens, you somehow can substitute like web mining fact checking with just learning fact checking. That's one approach. Then probabilistic approach in general, fact checking as Markov decision process. Then this whole all steps I described assign probabilities. That's another approach. Then you have even broader way to think about it. You have language model, then you have retrieval system, not just for fact checking, but for a lot of things. And it's closer to modern Bing, I think, this architecture. So you don't use, basically you merge, you always, not just for fact checking, but for all purposes, you merge retrieve results and generate results. It's even broader approach. So like what I was looking today is just here. Okay, so I have conclusions for Truth-O-Meter. Now, depending on questions and time, I can go into.
Start with Q&A.
Yeah, maybe give the people on the Q&A a chance.
Okay.
I think
the question, what if there's no definitive answer that can be found on Google? For example, ChatGPT has roughly 1 trillion parameters. 100. So if it's not on Google, so it means nobody ever in the world talk about it openly. I would be suspicious. So this is my philosophy of this. If whatever fact nobody ever discussed in open forums, never, then I would say it's unlikely that it is not a hallucination. It should be a hallucination. Then what if you trained a new LLM on only corrected information? Would the system exhibit better truthfulness? I would say no, because I mean it is trained on correct data. It's just that by the nature, by using only probabilities of tokens, how can you always be right? Again, deep learning people might disagree with me, but intuitively, so again, language model, it's still this classical, simple nearest neighbor learning. You have, you need to predict something, you have a question, and then you find similar example. Just borrow everything from similar. Like, I don't know. Yes.
I think it's based upon the public data. If you can predict what's in the closed forum in the non-public data.
If it's non-public data, nobody ever talked about it.
No, I'm trying to predict what's in the non-public data based upon the public.
Okay. But then it cannot be fact-checked. And using this approach, it will be rejected. If you try to predict what is not public data and you run, and then it cannot be fact-checked and it doesn't look opinionated, because like personal discussion, maybe a lot of opinionated data, and it will not be fact-checking opinionated data. But if it sounds like factual data, the system will reject it. Maybe it's not, but that's a philosophy. That's how approach works. If nobody ever talked about it, most likely hallucination, not like a new, bright, original idea. So it might kill like bright, original ideas this way. So I will try to answer this question. I'll read it again. What if you train new LLM on only corrected information? So again, a neural model and transformer that still can be reduced in most cases, and it's with some approximation to kernel machine and then to nearest neighbor learning. And I mean, if you have time, I can talk about this deeply. And I don't intuitively feel how nearest neighbor learning can be 100% correct. So they're always going to be hallucinations in domain where when you average and there is not enough data, you will always hallucinate. It doesn't matter that your source is truthful. If your source is not truthful, then you will hallucinate more. But even when you start from 100% truthful source and you apply kernel machine, which is essentially neural network, in a less represented subspaces, you're still going to hallucinate. That is how I understand.
I mean, also, if you look at any language model that's capable, that's been given the ability to write fiction and to write fact, I mean, it's sort of natural. It's like, of course, it can write incorrect things because it can write fiction, right?
This, and most importantly, there's not big difference about writing fiction and writing because it's still probabilistic. You're still finding nearest neighbor, nearest plausible closed neighbor. Okay. Then question: if people will publish all the ChatGPT hallucination on the web, people will be able to find it on the web using Google as fact eventually. Okay.
If you say if
that is
a
true.
web page called hallucination.
That is true, but Google, I'm sure Google is working very hard on not to index hallucination and rank it. I mean, that's Google. So for now we can trust it, but okay, I should mention about 2013, I had a proposal when I was working with this fake content, back then deterministic fake content, how one big search engine can kill another search engine by producing a lot of fake content, so that one search engine lost, one search engine cannot differentiate between fake and genuine content. That's a death of it, because people will see it. And so that was like my proposal 2012, like before language models and before just deterministic crossbreeding. Like if you have like 100,000 reviews from Amazon, eBay, whatever. From 100,000, you can produce, I don't know, millions of fake reviews. And then if you can spam search space, then search engine can get confused what is real review, what is crossbreed. And then is a problem, because then probably for users, because users will feel, real humans will feel, but back then, not anymore. That was 10 years ago, now it's not possible. So again, the answer is search engine will identify hallucinated content. Then question, how does Truth-O-Meter not consider conspiracy theories fake news as truth? Again, I trust search engine. If I think it's okay if it is a conspiracy and it's published on the web, and language model writes it, repeats it, okay, I think it's acceptable. So I don't consider that is not hallucination.
Is there any sources that you, when you're doing your fact checking, that you say, I'm not going to go to the Onion because I know that's sarcasm. I know certain, I mean, if there are certain sites or
sarcasm, I go so I classify factual and then opinionated as sarcasm altogether. Sarcasm has a lot of sentiments. So text with a lot of sentiments, I don't touch.
Okay.
So let ChatGPT like invent and sentiments. That's okay.
Okay.
It's not the job of, because then human consumers will know that's opinion. ChatGPT can have any opinion about anything. So we don't. So sarcasm is a part of opinionated data.
Okay.
One quick thing. I heard a lot of comments on this. It seems a lot of people are getting stuck on the word fact and truth. It's called Truth-O-Meter, to be fair.
Okay.
But the powerful statement you said is you're just trying to see, is it a hallucination? Because, what is a fact? What is a truth? I mean, we're not going to do philosophers. I just want to emphasize the important thing that you raise is that you're trying to see if it's a hallucination or not. Because that's what LLMs do, is hallucination.
Maybe it should be called a hallucination-o-meter.
Yeah, okay.
Because the opposite is fact.
So true. I'm supporting your stance, Boris, because that's what LLMs are famous for, is hallucinations.
Yeah.
And so that's I think you're solving
Because
that problem.
web doesn't contain only truth. So I would say truth according to the web, which obviously can be conflicting. So again, if humans write about it on the web, then it's the truth. Okay, last question. What if Google search out of Wikipedia entry is wrong? This happens for current events before Wikipedia editors have corrected things. I think, if Google, in this case, my truth-o-meter basically will make errors. It might offer wrong edit, which shouldn't have, or it might confirm hallucination.
But you're doing the best you can with the tools you have available.
Yeah, because I assume,
Exactly.
I assume Google and Bing true. So there are special cases when they are wrong, but okay. As I develop, they will fix it eventually. And it mentioned they fixed it. But so that's obviously because I rely on search engine. Whatever limitations in search engine, obviously, they carry on to truth-o-meter. How are we doing on time? I think.
I mean, if there's other questions, it's fine. I think we're fine. I mean, can you speak to just the whole problem of hallucinations, just to more intuitively help people understand it? What's written in the literature about how hallucinations are generated? You say you were talking about the nearest neighbors, and so if you're between two nearest neighbors, there are facts, but you're in between. You can be generating a hallucination, or you're mixing things, part of one story and part of another story, to make a hallucination.
Yeah, exactly. So a language model assumes the possible space of stories is continuous, but it is actually discrete. So when you start, so nearest neighbor, you're writing new stories based on the probability of tokens. You start with one typical story, then you switch to another typical story, then you switch to a third, and one of the switch, you basically makes it inconsistent. Because again, it is nearest neighbor. You always find a neighbor. You cannot have one neighbor because for sequence to sequence learning, for different parts of sequence, you use different original sequence. So yes.
So if Google has split results, like first and second answer in Google, they are
Yes.
contradictory. So it's a population is split. Like
Okay, so
50% believe
okay, so first of all, I apply this. So first, if I have only two, then I will consider third and fourth. And maybe first and second contradictory, but first is confirmed by third and fourth, and second is not. Then I choose one. It's approach number one. If I only use two, and I can only confirm with, so Google will give you multiple documents. And if whatever language model writes confirmed by individual documents, I accept it. It's not hallucination anymore. So again, two ways to look at it.
What's your next step?
Okay, so first, so let's take a higher level view. And in my practical career, I said, so I'm fixing, repairing results of deep learning. I'm repairing entity extraction. I am repairing domain classification. So what's the general architecture for repairing deep learning results? And why do you need to repair? So advantages of deep learning, maybe I go to the slide. Advantages. Advantages of deep learning that it's very efficient, so, and it covers huge space. Disadvantage that it's unexplainable and hard for human to do feature engineering. In a lot of cases, you don't need, but in many cases, you need feature engineering. Advantages of like nearest neighbor or rule-based learning, it's always explainable. You know, oh wait, this is a neighbor. You understand why. Like if in case of story, you first borrow story from your first friend, then from your second friend. You understand who your friends are. You understand the story. Everything becomes clear. So each part has its own advantage. So how can we merge deep learning and explainable learning? And that's obviously a question discussed a lot by community. And I think truth-o-meter, a generalization of it, what I call the shape charge learning. In general learning architecture, how you combine, and why I call it shape charge. First, you have a huge space, and deep learning covers, like the missile flies all huge space. Now we're in vicinity of the prediction, very close, and now we can make it explainable. So the huge space is covered by deep learning, and local space is covered by explainable learning. That's the idea of architecture. That's kind of generalization of approach. apply to question answering because you can similar improve question answering, apply summarization and other NLP tasks.
And local here means like checking a single sentence. Is that?
So deep learning moves from a billion of sentences to 100 sentences, and for 100 sentences you can just compute similarity in structural way and explain. And for 100 sentences you know exactly what is what.
It's more tractable.
More tractable, but without deep learning you cannot find. It could be not necessarily deep learning, it could be just information retrieval, like inverse search index. Inverse search index also reduces from million search results from million to 100. But finally, you have to be able to explain why, like how you got your result, why this prediction.
Can you put a link to your slides in a meetup discussion
Yes, I will.
later on if people want to look at
Yeah, I
papers?
can.
This could be a dumb question, right? But I was thinking like, why something like this is not implemented by the makers of argument itself on top of it? Why is it decoupled and then it's an accurate research right now?
I mean, there's a big active research now. So it's a very important question. So what I'm proposing, why doesn't OpenAI do it? Why doesn't Bing do it? I think they do it in some way. But maybe they will not tell how. Maybe they're doing something similar.
So this is the third party and it doesn't have any programming base or anything.
Of course it will.
It's your work. Yeah, okay, great.
So obviously it's the biggest bottleneck for language models, and it's a multi-billion business now. Obviously there are.
What are the failure modes of your approach?
So it finds some most frequent problem, stupid correction suggestion.
Okay.
So I'm fixing that. Also trying to find all all totally wrong correction and understand why. And number two, cases like false negatives, cases where it shouldn't be corrected. Because of my matching algorithm, I cannot find proper source on the web, although it exists. The way sentences specifically expressed like that, I cannot find information for it, but it exists. So this is problem number two.
A lot of applications that might use a large language model might be narrow in focus or narrow in domain. So if it's like your company's documentation on whatever subject. So if you have it more narrow, do you think your accuracy rates or the improvement would go up?
Yeah, and honestly, I think that's more promising because I think sooner or later, Bing and Google,
I mean, especially if you get Bing or Google.
yeah, they will
fact
cover,
search
they will do fact checking, but
your
for
documentation.
specific domain, then truths become exact, because then you have intranet. Like for example, particular financial documents for particular bank, then it's not general knowledge anymore. Then I cannot just find any document, then it has to be specific document. Then fact check, this architecture going to be the same other than this logical conflicts. They should not be conflicts.
So if it's inside a firewall, not indexed by Bing or
Yeah,
Google,
then I
you have to
think
use Lucerne or something.
Then I think that's so I believe that's more realistic application of this technique in the future, because again, sooner or later, bigger LLM companies will make it will make fact checking against the web themselves. But for specific companies, answering specific questions and writing about specific topics, that would be a technique to use. Because instead of using search engine API, you just use local search engine. There's no difference in overall architecture. It's the same logic. So I think that would be more promising direction for this approach.
One other thing too. So there's the finding the mistakes, the hallucinations, and there's the correcting the hallucinations.
Yes.
I was wondering, like, I notice a lot of times when I'm using GPT-4 that it says something incorrect, and I'll say, actually, that's not true. Or actually, he was 15 when that happened, or something. And it was like, oh, you're right. And I'm corrected. Here's my rewrite. Does that is that a reliable way to I mean, if you can detect the hallucinations, is that a reliable way to, converge to something that doesn't have hallucinations?
Yeah, so I will repeat. So if you use internal It's like so human is in the loop. Human identifies wrong. Human notifies. Human notifies. That is what I call iterative fact checking. That so second approach, iterative fact checking. So you come back and tries. Your prompt is like redo the same thing given that fact, but it might still hallucinate, and then you have to do it again. And then you don't really understand because then you don't have references. With fact checking, you when you write, you can always back up saying you confirmed, and for each sentence you find the source. And if it's still after iterations generated by language model, you still don't have official confirmation. You don't know what the source, where you got it. Maybe it averaged, just applied averaging different documents and just was lucky to guess properly, but still there's no citation, no source.
Okay, I guess we,
Last question.
any other questions? Go ahead.
Is there a way I can have a, where I can use this, because, like, what's the reliability, like, can I use the life sustenance, like ambulance or hospitals?
I suggest, okay, first just student like coursework, just factual, avoid factual errors in student, like use ChatGPT, but fix factual errors in student work. Medicine, yeah, it's kind of my dream, but it's much harder. Well, the start would be just like basic writing. Don't make mistakes in basic writing. Like, for example, like travel, marketing, right? Use ChatGPT about particular place and then correct errors. Because it's invented, real travelers would go, they would expect one thing, but turned out to be very different. Just like normal, like stop lying in marketing documents. At least there. At least there.
What is that?
Yes.
Have you made this open source? Like, can somebody go and make like progress on it and use it, or like is it licensed? Or how does
So I just have standard license. I can go to try to
Is it
go to
Apache or?
yeah, Apache license. I can add anybody. You can send me a pull request if you want. Like code is also open. So to run the code, yeah, obviously happy, very easy to run. It's just like a couple of lines of code. You get it from you get the library. The only thing you need your own Bing key because it's a commercial thing, but it's free. I mean, if you don't run thousands of documents, you can run free. If you don't run 10,000, you get free Bing key. Then you can just use like a few lines. You just use my library, call it, you pass it sentence text to verify, and you get back corrected correction report. That's how it works right now, correction report. And then you can do this correction report, whatever, in your application, whatever you want. Yeah, I would be happy to.
This sounds like a really impressive amount of work. I mean, I'm really impressed. I mean, you've done a lot of stuff here.
Yeah,
Very,
yeah,
very
there's
interesting.
a lot of different approaches you have to solve the
Yeah.
problem too.
Yeah.
Very good.
We'll do fact checking on you.
Well, thank you. Help me thank our speaker. So we'll have a next talk will be at Hacker. Well, we have another a couple of other upcoming talks on the SFA ACM. Look at the meetup site. So there's a couple there. So the next one is going to be on a Friday. That was the human resources one. And then there's another one on the future of AI that I'm giving in about a month on July, I think 25th or whatever that Tuesday is. So thank you for coming tonight. If you have any plates or anything, if you could take them to the trash on the door on the way out, that would be great.
Just to let you know, there are other events.
In about a month on July, I think 25th or whatever that Tuesday is. So thank you for coming.